Hello everyone, welcome to the 12th video of our 100-day biopharmaceutics challenge. So we are here to cover the drug metabolism part. We are already done with our drug distribution and drug absorption distribution, right? So we are back with the drug metabolism part. While we are talking about the drug metabolism part, definitely we are going to chit chat more about the major drug metabolizing organ, that is going to be the liver. However, we already have a lot of different organs. We have lungs, adrenals, kidneys, we have skin, as which independently also act as a metabolizing organ, right? So by metabolism, what exactly we mean? This metabolism will actually convert drug into its active or inactive metabolite that is ready to be excreted. This is what we can say. So it is generally most evident that we have different reactions that will come into play with the several enzymes that are present, which will metabolize your drug, convert it into a more hydrophilic part, right? Or an inactive part, or can make it even active metabolite. So drugs can be converted into their metabolite using such biotransformations, right? So this biotransformation, the major organ for this biotransformation, or which I think you have must have covered about the pre-systemic metabolism, how the liver comes in play using its enzymes to actually biotransform, metabolize your drug and reduce its bioavailability, right? So in the liver, we have different types of enzymes. So we have to cover the microsomal enzymes and we have some non-microsomal enzymes. Microsomal enzymes or non-microsomal enzymes, ultimately they are going to fall short, but they are going to metabolize your drug, convert it into a metabolite. In the metabolism, we have phase 1 reaction, we have phase 2 reactions, right? Phase 1 reactions actually include your functionalization reaction. Which multiple reactions do we have? We have a simple trick for it. We can say orchard here, right? So we have oxidation, reduction, hydrolysis, cyclization as phase 1 or functionalization reaction, whereby you add a functional group so that you convert it into a more hydrophilic metabolite or more polar, right? Then you have phase 2 reaction. In the phase 2 reaction, we call it as conjugation reaction, right? In this conjugation reaction, we have several non-microsomal enzymes that majorly come in action, help get drugs that get metabolized by phase 2 reaction. Generally, we have a trick for this also. You can say we have games: glucouronide conjugation, glutathione conjugation, acetylation, methylation, amino acid conjugation, and sulfonation. All these reactions have their own precursors as well. They have their conjugating agents as well as the enzymes are different for each reaction, right? So that is why I initially mentioned that liver is a tricky organ, metabolizing organ, which will encounter help, which will ultimately lead the metabolism of drug. Suppose this is the drug that you have administered. First, in the liver, it enters phase 1 metabolism, functionalization reactions comes in play, oxidation, reduction, hydrolysis, cyclization, convert it into an inactive metabolite which is now ready to be excreted. So the whole purpose is what? Whole purpose is to make it as an inactive metabolite, but there is a possibility you can also use as a prodrug approach. That means for certain drugs which have as such limitations of solubility or taste masking, for example, you have the best example of chloramphenicol. Such drugs includes prodrug strategy so that the form, salt form that is actually they're used and then they're converted into an active metabolite post their metabolism, right? So that is the prodrug approach whereby this metabolite remains active. From inactive drug, it converts into an active metabolite. Okay. But here what we have to simply cover that drugs undergo phase 1 reaction, converted into inactive metabolite ready to be excreted. Otherwise, they will enter phase 2 reaction whereby they will meet a conjugating agent. They will have to encounter certain non-microsomal enzymes as well. These agents will bring down it to become even more inactive so that it is now ready to be excreted. So based on their size, the drugs can have renal excretion as well as biliary excretion. You already know about it, that size play a lot of important role in the drug excretion and metabolism part. right? So phase 1, remember functionalization reactions we have. Phase 2, we have conjugation reactions. Phase 3 reaction, why it is written as transporters? Because in certain cases we have transporters like ABC transporters, whereby the most important example is of PGP, that is P glycoprotein. These actually behave as efflux pumps. These throw out your drugs out so that they do not act, they do not show their action. They actually pump it out as a foreign body or as a toxic compound and just try to take it out of the cell or the organ if they try to flush it out. So PGP, these transporters also try to minimize the action of drug, make it a hurdle. They can be a reason of the chemo resistance as well, right? So we have drug metabolism as this. But yes, this is not the complete explanation. This is a short video to make you more get familiar with the introductory concept, and then we will move to the separate reactions which are very important from your exam point of view. So stay tuned, meet you in the next video.